Hi everyone, thank you for joining today's session. Today we would be talking about attenuation concepts and also would be starting WLC and AP introduction session. In the previous session, we have understood how RF signal is generated, propagated, and detected at the other end, and what all factors can affect while the transmission is in the air. So when you want to transmit some information through the air, so what things can affect and how you can transmit, what are the shortcomings, and how exactly we are transmitting the information from point A to point B is what we have understood till now. So we have reached end of the wireless foundation module 1, where we would be today learning about the attenuation and closing this topic. And in the wireless modulation too, we would be learning little more concepts, high-end concepts like OFDM and Fourier transforms and other concepts like the band select, band steering, coloring, BSS coloring and all. So that all will be covering in the wireless module 2. So after the wireless module 1, so we would be touching the wireless access point and the wireless LAN controller, how they work, architecture, deployment. So all these things we would be looking at. So let's get started with our session today. So attenuation. So attenuation is nothing but in simple terms is any obstacle that is interfaced in the transmission journey. That is nothing but when you send the transmission from point A to point B, when you send the RF signal, or you call it as a transmission, or else any signal, RF signal that you are sending. So if any obstacle, it hits any obstacle, so that is nothing but attenuation. And also the causes of attenuation is not only the obstacles that are there in the medium, but it can be the free space path loss. If you remember, we have seen the free space path loss in the previous session, like over the time when the wave is traveling in an open space, and as it travels, it behaves like this, where its energy is lost, like it gets degraded basically, right? It is similar to the ripples that gets generated when a person is putting a hand into the sticking a finger into the pond, right? So that's what happens when that's exactly what happens when the radiation gets transmitted on the free air. So attenuation is a general term that refers to any reduction in the strength of the signal. Several factors contribute to attenuation in wireless transmission. We will have a look for these factors one by one. Because of an attenuation, there is loss of signal strength. From our previous sessions, we have understood that when we tell the signal strength is decreased, that is nothing but the amplitude is decreased. And because of these, signal may not travel to the receiver, or it may affect in mutated signal as a mutated signal. So as you can see here, this is one of the tool, okay, where you can simulate the attenuation. If possible, I will just show this tool. So what happens is when our radiation or a wave or a signal is traveling, suppose it gets in its journey, it comes across a concrete wall. So how much dB attenuation it can have? Like normally the concrete wall will have like a 3 dB attenuation, right? So you can see the signal strength getting decreased once it passes through the concrete wall. Once the radiation hits the wall, so in what cases it can reflect, it can deflect, it can refract, or it can scatter. So that is what we would be seeing. Okay, that is the behavior or the characteristics of the wave, where it goes and hits a object and how it behaves, and whether the signal strength will decrease, or obviously it is going to decrease, because when it passes through the wall or any water objects, so the water objects is having the highest attenuation. Okay, when it passes through the when you send the radiation or when you send the RF signals, if it encounters any water bodies, so that will cause attenuation. For instance, in your office, if you have bookshelf and there are a lot of books, and it is made up of wood, right? The paper material. So that paper material is made up of wood, and wood is having the water percentage is more. So that will cause more attenuation. So those kind of things that you need to look at, where the attenuation can cause the obstacle that it encounters has more attenuation when there is a water body. So types of attenuation: reflection, absorption, scattering, refraction, and diffraction. So let's see, first is the reflection. Reflection in Wi-Fi refers to the phenomenon where wireless signals bounce off surfaces such as walls, floors, ceilings, and other obstacles. Okay. So reflection occurs when a wave encounters a surface that cannot pass through and bounces back. Okay. So in this, what happens is, um the wavelength is smaller or comparable to half the surface length. So whatever the surface length is there, right? So the radiation that is thrown, or the radiation that gets hit by this object, so if that wavelength is half the length of the object that is hitting, so then it will reflect. So that is the logic. Okay. If the wavelength is half or less than that of the to the material that it is going to hit, so then it will reflect. Okay. So reflection is significant with the wavelength of the wave. If it is smaller than or comparable to half the surface length, it hits. For example, if you want to take a real world example, a mirror reflects light because the surface is smooth and the light waves are much smaller than the mirror's dimensions. Wi-Fi signals reflecting off a mirror like this. When Wi-Fi waves hits a large surfaces, part of the signal is reflected back like this. Okay. When we point a laser towards a mirror, the laser beam propagated from the laser pointer will reflect the other part of the space. This is an example of reflection. Physical barriers like walls, furniture, building, and materials like metal, glass, concrete reflect signals differently, affecting signal strength and quality. Reflected signals arrive at the receiver from different paths, causing the signal to arrive at different times. Okay. Um, in our previous classes, we have learned that multipathing. So one of the causes of multipathing is reflection. When the signal goes and hits the ceiling or the floor or any object in the office, so then the signal gets reflected, and the some part of the signal gets mutated, and that will come as a new signal or a mutated signal on the receiver end. There is a main signal that comes and a mutated signal that comes. Now there are two signals that are with the same information going to the receiver, right? So that's the multipathing. So one of the cause of multipathing was reflection. Okay. So when you send the radiation, its behavior is to reflect. So when it is going to reflect, when it is this, it depends on the surface as well. Okay. And also if the wavelength is smaller, the wavelength of the wave is smaller or comparable half of the length of the object that it is hitting, so then it is going to reflect. So that's the analogy. That's a pretty straightforward one and a simple one. Then we have the absorption. Absorption occurs when a wave loses its energy to a medium like this. Instead of reflecting, it will pass through. Okay. When it occurs, when it loses some energy, but it will continue to go in the same, it will pass and continue to travel. So why it will travel? because when the materials molecular structure resonates with the wave's energy, converting it from one medium to another medium. So then what happens? It is allowed to pass from one medium to another medium. Okay. And as you can see here, absorption is the process where materials take in energy from electromagnetic waves, converting it into other forms such as heat. Okay. And it will go from one medium to another medium. And also when any object is, some part of the signal gets reflected, right? So some part will be absorbed by this material as well. It is not only the reflection that happens, but the absorption also happens. Some part of the, you are sending the signal at some particular dB. When it is hitting here, so it will be very less dB. Okay. Some part of the signal will be absorbed. Some part of the dB will be absorbed. Signal strength will be absorbed. In wireless networking, absorption can occur in atmosphere, walls, furniture, and other objects, leading to signal attenuation. Some materials like walls and water would absorb the potential energy of those signals. Different materials have varying degree of absorption. Water and concrete are strong absorbers of radio waves, while air absorbs much less. The absorption properties of materials depend on their molecular structure and frequency. So one question for you, like whether these radio waves, radio frequency waves, do they travel in vacuum or not? Okay, just try to find out, and if possible, let me know. The absorption properties of materials depend on their molecular structure and the frequency of the wireless signal. It all depends on the frequency, because frequency is related with wavelength, right? So frequency is inversely proportional to wavelength. What it means? Wavelength is nothing but the distance between two crusts, or else it can be a distance between two crusts, two troughs, right? This is the wavelength. So when you increase the wavelength becomes larger, the frequency will decrease. Okay, when you increase the frequency, the wavelength will be shorter. Okay, when you decrease the frequency is more, the wavelength is when you increase the frequency, sorry, when you increase the frequency increases, then the wavelength decreases. When you decrease the frequency, the wavelength increases. So that is what the relationship between the frequency and wavelength. And what is the logic why I am explaining this? That is because the radiation that you send, if the wavelength is like smaller than the object surface, object length, so then it is going to reflect. Some part of it is going to reflect. Plus, also it depends on the material that it is going to hit. Okay, density of the material, that also matters. Okay, so that's the reflection. And absorption is the signal's energy will be absorbed by when it passes through a material. Okay, some part of the signal will be absorbed even if it reflects, but still some part will be absorbed. So completely when it will be absorbed. So in cases like we can say like microwave ovens. Okay, so microwave oven has a wavelength that resonates with water molecules, and whatever whatever food you keep in the microwave, right? So what microwave is going to do? It is going to ignite or ignite the water particle that is present inside that food, so that it will ignite. So making the vibration and it will heat up the food basically. Okay, and the microwave, in the microwave oven, the absorption happens and then it will vibrate the water body, the water material that is present in the food. Okay, we will not be able to see it, but it is made up of water, right? So that particular water molecule, so that it will be vibrating and it heating up the food. Okay, that's what the absorption can do. So absorption phenomena is used in the microwave ovens. Okay. So that's how it works. And also for absorption, you can take like colored objects. For example, a red T-shirt reflects red light but absorbs other wavelengths. They don't resonate it. So those kind of examples you can take for the absorption phenomena. So then let's move on to the next one. Scattering. So scattering happens when waves encounter small particles. Here, basically what happens is the is wavelength is bigger than the particle itself. For example, moisture, the air, right? Air moisture. Suppose if the waves hitting the moisture and the wavelength of the wave is larger than the particle itself that it is hitting, so that time the scattering will happen. For example, here you can see a flashlight flashing it on the mirror ball, and it is scattering the light in many directions. So this is what scattering means. And it happens when the wavelength of the wave is bigger than the particle itself. Okay. So that is when the scattering happens on the small particles or irregularities, and it gets deflected in multiple directions. So that's what the scattering is. Scattering is most effective when the wavelength is comparable or smaller than the size of the particle. Uh, I think when the scattering happens, the wavelength should be more. Okay, the wavelength should be more. So then only the scattering happens. I think, oh, sorry. So when the scattering will happen, when the wavelength is smaller, actually, wavelength should be smaller. Wavelength is larger in the diffraction, basically. But in the scattering, it should be smaller and smaller than the size of the particle. So then it will cause scattering. For examples of the scattering is like the sunlight shining on the objects, right? So that is because of the scattering. And when the sunlight enters the Earth's atmosphere, right, it interacts with the air molecules, and shorter wavelengths like blue and violet. So if you look at the electromagnetic spectrum. So the light is in somewhere in the middle, right? At at the left side, you have the radio waves, microwaves, and here you have the gamma rays, X-rays, and all you are having, right? So this is nothing but VIBGYOR. So why human eyes will interpret only blue color? Because that is more our eyes can interpret that particular frequency. That's why we can see the sky as blue. Shorter wavelengths like the blue or the violet. Okay. Um, when the sunlight enters the Earth's atmosphere, it interacts with the air molecules, and the shorter wavelengths like the blue and violet scatter more than the longer wavelengths like uh, like the red and the yellow. So these are having the longer wavelengths, but these are having the smaller wavelengths. This is because the shorter wavelengths are more easily deflected by the smaller particles. So our eye sees blue instead of violet because the sun emits less violet light, whereas our eyes are more sensitive to blue than violet. So that is why whenever because of that frequency, so we see sky as blue. Okay, that is one phenomena. And so shorter blue wavelengths scatter more in the atmosphere, while longer wavelengths like red and it dominates at the sunset. But mostly blue is what we see. So the signal is then scattering in wireless networking refers to the phenomena where a wireless signal is redirected in multiple directions as it encounters obstacles or irregularities in propagation medium. This can lead to signal degradation and affects the quality and reliability of wireless communication. Weather conditions such as rain, fog, and snow can also cause scattering, affecting outdoor wireless communication. To mitigate scattering techniques such as beamforming, spatial diversity, we have seen this, right? Beamforming, spatial diversity, MIMO can be used to enhance signal quality. Mm. Absorption, scattering. So there is one more phenomena that is called as diffraction. Okay. And diffraction is nothing but bending of the light. Suppose if you have a cup of water and you put a straw, so you can see the straw getting slightly bent in the water. So when a signal pass from one medium to another medium, so it gets deflected. Okay. It gets deflected. So diffraction occurs when the wavelength of the wave is larger than the size of the obstacle. Okay. For example, if a wave is traveling like this, it comes across the obstacle. So then the radiation will go like this, not absorbing, not reflecting, or not scattering, but instead it will go from the side like this, the radiation. So that's a phenomena of diffraction. So when it will happen, when the wavelength is larger than the object itself, when the wavelength is larger than the object itself, so then it is going to go in the sideways like this. So that's the concept of diffraction. So as a wireless engineer, you should know the characteristics of the waves, right? Like how it behaves and what will cause the radiation or the what will cause the RF signal transmission, and how the attenuation happens and what are the causes for it. So as a wireless engineer, knowing these things is always a plus. Okay, so we have understood reflection, and there is one more phenomena that is refraction. Okay, apart from the reflection, refraction, scattering, right? Reflection, absorption, and scattering we have seen. So next we have seen the diffraction, and one more thing is that is refraction. So refraction occurs when a wave passes from one medium to another medium, and that is also change direction due to change in the speed. So that is when the refraction happens. And refraction happens prominent when the uh, wavelength is like uh, so refraction happens when the surface that it is hitting, right? So that is more thick than the wavelength or than the wave itself. When the boundary is thicker, so that time the refraction happens. So these are the attenuations that are present in the environment that a radiation goes through when it is transmitted over the air. Okay, so we should know this attenuation concepts. So now let's focus on wireless LAN controller and access point. So this is the topics: introduction, install and deploy, initial configuration. So today we will deal with the introduction part. I hope you got the concept of attenuation. If any questions you have, you can ask, or else we can go with the next topic, that is WLC. Yeah, I take that as yes, you have understood. So before going to the WLC, so there is one more concept that I wanted to explain you. That is nothing but voltage standing wave ratio, VSWR, or the voltage standing wave. So voltage standing wave ratio, it is a measure of how efficiently the RF power is transmitted from the source to the load, that is nothing but the antenna. Okay. So how efficiently it can absorb the AC signal or the power that is transmitted from the transmitter. So that's what the VSWR is. It indicates how much of the transmitted signal is reflected back due to impedance mismatch. So if there is any attenuators that are there, lightning arresters that are present, or any signal boosters are present, and the antenna cable, so they all should have the same impedance. Impedance is nothing but the resistance. Okay, impedance is nothing but the resistance. So why we are resistance? Resistance is nothing but, suppose you are sending a signal at 20 dB from the transmitter. So the antenna cable is going to introduce the noise, or it is going to introduce some um friction in form of resistance. So that resistance, it will be calculated in ohms. Okay, maybe it is 5 ohm. And then the attenuator or lightning arrestor. So it will have 2 ohm of resistance. Then again, it is having a 10 ohm of resistance. So when there is a impairment in the resistance, so then it will create, this concept will come like the VSWR. That is nothing but voltage standing wave ratio. When RF power travels from a transmitter to an antenna, okay, it should ideally all be absorbed by the antenna. Whatever signal you are sending, so it should be absorbed by the antenna. However, if the impedance, that is the resistance mismatch, happens like this 5 ohm, 2 ohm, 10 ohm, then uh, then uh, uh, then the signal will have signal to noise ratio will not be good, and also the signal will be very bad. Why it will happen is, for example, suppose you have a pipe and you have a water source, and water is gushing out of this tank, and there is a larger pipe like this, and the pipe will have a narrow will connect to one more narrow pipe. So now whatever the water that is gushing out like this, so some part of the water will be reflected back. Okay. So the same thing happens when you have the different resistance values introduced by the cable, lightning arresters, boosters, and all. So each material that is between the and the transmitter and the antenna, so it should have the same impedance. Suppose if the cable is having 5 ohm of impedance, the lightning arrestor also should be of 5 ohm of resistance. If there is a mismatch, there is an impairment in the impedance between the transmitter and the antenna, then the reflection will happen. So that is indicated by, you are sending the maximum Vmax, voltage max is equal to voltage minimum. That is nothing but, you are sending the signal at suppose voltage 1, and the minimum is also 1. That means, what that means is, like, this is the best, this is the good VSWR value. Okay. So why it is, I will explain. So as I said, when there is an impairment in the transmission from transmitter to the antenna, some of the signal gets reflected back towards the source. So this creates the standing waves, which VSWR measures. Okay, some part of the signal will be reflected. So good impedance match is equal to, if you have the low VSWR, okay, then it is a good impedance match. If you have the high VSWR, means that is not a good that is a bad impedance match. That is happens because of the reflection and power loss. as there is an impairment in the different objects that the signal is passing. Okay, as I have explained here, suppose you have a um, uh, pipe and it is of different sizes, and then when the water gushing out of the water tank, some of the water gets out of this smaller pipe, but some will reflect it back. So that reflection will create a bad signal, and all of the signal is not absorbed by the antenna. So how to avoid this is to have the impedance common across all the components. So while purchasing, you need to choose it like that, where the impedance should be almost the same. So that's what the VSWR, and this VSWR is is a measure of how efficiently RF power is transmitted from a source to a load. So that is what it will tell. For example, 1:1 VSWR means it's a perfect impedance. So where all transmitted power is absorbed by the antenna. You are transmitting like 1, and the absorption is 1. So that is what 1:1 means. That's a perfect match. Okay, you are sending signal 1 and you are receiving absorption of by the antenna is 1. So that's what 1:1 means. Suppose if you say 2:1, it indicates the power loss. You send signal 2, but you are receiving by the antenna is 1, because 1 is getting reflected back. So you are sending signal at 2 times. The voltage you are sending is 2 times, but 1% of that is going to be reflected back. Only 1% of it is getting absorbed by the antenna. So that's what this 2:1 means. Okay. So 2:1 indicates one in the this one, right? So this one indicates the loss due to reflection, and reflection by the uh, reflection in the during the transit. So what is the ideal ranges? 1:1 is the ideal range, and also 1:1 to 1:5:1. Okay, this is also excellent match. So that is nothing. Sorry, 1.5:1. So this is also excellent match, that you are sending 1.5 and your 1 is getting reflected. Okay, 1 is getting reflected, 0.5 is getting absorbed by the antenna. So that is a good, excellent match. And also 2:1 is also acceptable by many applications, but 2:1, anything above 2:1, right? So that's a poor efficiency and needs correction, and impedance matching should be there. So how to achieve 1:1? So there are ways to achieve this. Like you can have high quality coaxial cables. Then you need to have the proper impedance match should be there, and those all things. And also while purchasing, you need to check the VSWR values of each component. So that's the only way. And why VSWR is used? That is because it tells the efficiency of the transmission between the transmitter and the antenna. So how much signal it can absorb. So how much part of the signal gets reflected because of the resistance that is there between the transmitter and the receiver. So that's what the VSWR is. VSWR ratio gives the total, the maximum voltage that you are sending to the minimum voltage that is getting absorbed at the receiver side. That is the, sorry, not receiver, the antenna side. Okay, how much signal the antenna is absorbed. So that's what the VSWR is. Okay, I hope you got that concept. So yesterday also when we were checking the data sheet, so you have seen that VSWR value, right? So so now we know that what is 1:1. One is the maximum voltage that the transmitter is sending. One more one is, that is this one, minimum voltage that the antenna is absorbing. Okay, so that's what. Vmax is equal to Vmin. So now let's see the concept of wireless LAN controller and access point. First, the introduction. So what is a wireless LAN? So what comes to your mind when you hear a WLC or when you hear a access point? So when we hear something related to the access point, the first thing that comes to your mind is the home Wi-Fi. That is the access point with two antennas, right? So this is our understanding about the wireless. But from past few days, we have understood many concepts how the wireless operates. But today we are going to learn the application of it, meaning we would be looking how we are going to use this technology in our Cisco devices and how we create a ecosystem that will cater the clients for the communication, wireless communication, catering the clients with the best data rates possible, with the best data rates, with the best throughput possible. So to achieve this, to achieve the wireless communication or to create the wireless LAN infrastructure, okay, so we need to have two important components that is called as WLC and the access point. These are the two main components in the wireless LAN infrastructure. If you want to do wireless communication within the corporate networks, then you need to have these two components as a must. So nowadays, things are changing and WLC part is going into the cloud where only we are deploying the access point on the on-premises because of the zero vulnerability management in the organizations and also few other advances like automation and less infra management and all. The WLC is going to the cloud, but still the access point has to be on the floor, on the floor. So it becomes a must to understand the basic concepts of wireless. So unless we understand what is RF signal, how the signals are getting transmitted, what are the RF behavior, and what things can affect the signal. So without understanding that, it is not possible. You put a WLC into a cloud, or just on a lighter note, you put a AP also in the cloud. Does not matter. But at the end of the day, the client has to connect wirelessly within the corporate office. Okay. So we are trying to understand the significance, the importance of WLC and AP. So in any corporate office or any deployments, indoor, outdoor, so WLC and AP is required. So the AP can work independently when there is a smaller environments where you can have the autonomous AP, which can do the management stuff and a few other things. So there is a concept of split MAC. Okay, so those all things we would be learning one by one. So, but what is a WLC? WLC is a centralized device in a wireless network that manages multiple access points. So WLC manages the access points. Okay, multiple access points. And access points are like the eyes of the wireless LAN, which gives all information to the WLC, and WLC is the brain of the wireless LAN. Okay, and access points provide the real-time information of the clients. Access points sends the frame, receives the frames from the clients. A device that provides Wi-Fi connectivity to users by forwarding traffic between wireless clients and wired network. And I have already told you wireless LAN is nothing but an extension to your existing LAN network, right? So it is nothing but an extension to your existing LAN network. Wireless basically WLAN basically works in the layer 2, right? It's not a layer 3. It's a very small part, but as as the consumption of the wireless is getting more and more and the throughput is getting more, so the usage of the WLAN is getting more. Okay, as the communication is very fast in the wireless. So we have two kinds of architecture. So before going to that, so I hope you got what is WLC and what is access point. So WLC manages access point in a centralized fashion, where the access point is like a ice, and that ice are going to give all the information about the wireless LAN environment that is around it, the client's details and all the activity that is happening. So it will be fed to the WLC. So WLC will be centrally managing these APs. Okay. It centralizes the configuration, management, and security policies of the wireless network. And also it provides reliability, security, and ease of management. No matter you have a WLC on-prem or you deploy a WLC on the AWS cloud, or you are having some other WLC in the cloud, but the access point has to be on the floor and it has to provide all the data to the WLC. And the access point can work as an autonomous AP as well, where it can manage itself. Okay, when access point is managed by the WLC, so that access point is called as lightweight access point. When the access point does not connect to the WLC and it works independently, then it is called as autonomous AP. Okay. Access point, it serves as a bridge between the wireless clients and the wired network. So basically, the access point sits here and it gives all the information to the WLC relating to the client. Client is connected through the SSID and sending all the information, and AP is going to send it to the WLC, and then it is going to bridge to the wired network. Okay, wired network. And this is 802.11. Ethernet is nothing but 802.3. So now whatever information, it is just a extension to the existing LAN, right? So the AP bridges between the wireless wireless communication to the Ethernet communication here. Ethernet network, wireless network to Ethernet network. Either the AP can directly talk to the wired network, or else it can talk through the WLC to the wired network. So both ways it is possible, which we will learn in the later stages. But you should know that access point will bridge between the wireless LAN and the LAN. That's what the AP does. What are the key functions? Centralized management, security for enforcement, load balancing and traffic management, roaming support, quality of service, scalability. So when you have the WLC in your infrastructure, you can scale the scalability is good when you have the WLC as a master, and APs working as the eyes of the WLAN. If you have a single WLAN, it is like single AP. When you have a single AP, it works. It works in a very disconnected manner. When you are having multiple APs connected to the WLC, you have a centralized architecture. So it is very smooth compared to a single AP working independently. Okay, so depending on that, the WLC or the wireless architecture has two formats. One is a centralized architecture, one is autonomous architecture. In the centralized, it is like WLC is there, and WLC handles the part of the WLC handles configuration, authentication, security, and traffic management. Not in all cases, traffic management, only in few cases. And the access points, okay, access point operates as a lightweight access point. Okay, lightweight mode. It works in a lightweight mode. So the access point is basically uh, the first point of contact to the clients. Okay, it will just exchange the data traffic and whatever the authentication, authorization, the config, everything will be done by the WLC. So WLC will put all intelligence to the AP, so to operate. Okay, but in autonomous environment, everything will be with the AP itself, the authentication, security, traffic management, everything. It is well suited for the small offices. So this is the WLC key functions: centralized management, security, load balancing, roaming. You cannot roam if you are alone. If you want to roam, you need to have multiple APs connected to WLC. So that's the benefit of having a centralized architecture. Then AP functions, wireless connectivity, network bridging, signal coverage. Okay, basically the SSIDs, right? Data transmission, security management. So all these things. So that's what WLC and AP does in the wireless LAN. Okay, there are different WLC models that are available. Okay, so WLC, there is two architectures. Okay, one is a Air EOS software. These all uses Air EOS software, whereas the latest one uses iOS architecture. Okay, so the functionality wise, both offer same thing. Both offer mobility, RRM, guest access, everything same. Here also same features only. Only thing is the software is different. So here like 8.x versions are there. iOS versions are present. So both this is the older legacy models 3504. In our lab we have 3504 and also 9800. Okay, so the 9800, they can be deployed on the VMs. You can deploy it on the AWS cloud or any other cloud which is supported, and also you can deploy it on the ESXi. So you have a Dell server or a Cisco UCS server. On top of that, you will install the ESXi, right, for virtualization, and you can install the 9800. So multiple 9800 you can install because you have the ESXi virtualization hypervisor, right? So like this you can achieve, or else the WLC can be deployed on the AWS cloud as well. You have different models: 9840 for medium density, 80 high density. Then you have CW 9800H, M, L, and CL. Okay, so these are the new models of the WLC. So AP models, you can see these are the legacy one: 1800, 2800, 3800. In our lab, we have 3800, 3802 also. And this is the latest model: 9100, 9136, 9166. Okay, these are the latest model of the APs. And the difference is obviously the 9000 models, right? So they will support Wi-Fi 6, okay, and the 3800 supports Wi-Fi 5. These models will support Wi-Fi 5. So there are two kinds of APs basically, that is Wave 1 AP and Wave 2 AP. Okay. Yeah. So as I said, there is a split MAC architecture and local MAC. Split MAC architecture, the MAC layer functionalities are divided between the access point and the WLC. So now we know that the WLC and AP works in conjunction, like they work as a pair, and most of the intelligence on the WLC. WLC will push that to the AP, and AP will take the decisions based on that configuration that is pushed from the WLC. So that's called as a split MAC architecture. In this, the MAC layer functionality are divided between the access point and the WLC. Some tasks are handled locally by the AP, while others are managed centrally by the WLC. Tasks performed by AP. What are the tasks that AP handles? Frame transmissions, encryption, decryption, packet retransmission. Basically, it is the working horse of the WLAN. Tasks performed by the WLC: authentication, mobility management, policying, frame aggregation, dynamic RF management. That is all taken care by the WLC. It's like a master. Then there is a local MAC architecture. The AP performs all MAC layer functions without depending on the WLC. The AP is fully responsible for management and control of the wireless network. So if you, can I make a normal AP to autonomous AP? That is possible. You need to have a particular software for that. Okay, autonomous AP to the lightweight access point, you can convert that. Okay, and also you need to check the data sheet if it is supporting. And there is one important protocol that is called as CAPWAP. So in networking, this term is very important, that is protocols. Nowadays, because of the automation and all, that is all APIs, right? But in the older versions, it is nothing but the protocols. For example, when a device A communicates with the device B, you need to have set of rules. Suppose a device A talks English, device B also need to talk English. So then they can communicate with each other. So that rules is called as protocols. When a device communicates with another device, it needs to have set of rules, and that rules is called as protocols. For example, say he is a client, he is a server. And what is a server? Server is something which provides services. When a client is requesting an IP address, then they need to talk DHCP protocol. If the client is requesting for the FQDN resolution, or you can say if it is asking for host name to IP address to host name, then they need to talk the DNS protocol. Suppose this guy wants to share his routing information with him, then he needs to have routing protocols like OSPF, EIGRP, and all. Similarly, in the wireless realm, if a device wants to communicate with another device, and it is because like the WLC wants to communicate with AP, so that it can exchange information about the client. Okay, so that to talk between WLC and AP, we have got a protocol that is called as CAPWAP protocol. We have two protocols, that is CAPWAP and LWAP. Okay, but CAPWAP is the one that we are using. Okay, LWAPP is the older one. CAPWAP is the one that we are using, and this is a Cisco proprietary protocol. Okay, and it does not have DTLS. That is the drawback. Security is not there, and DTLS is not there, but it also works on the UDP. Okay, but here when you take CAPWAP, it is developed by IEEE. Okay, open standard, and it uses DTLS for securing the frames. Okay, so what is DTLS? DTLS is nothing but datagram transport layer security. It is a protocol used inside the CAPWAP to secure the control traffic. So if you know the latest devices like the SD-WAN and all, right? So the architecture is kind of split there. There is management plane, control plane, and data plane. So these are segregated, right? That means what? One of the master is going to manage the management and control, but the slave is going to manage only the data traffic. Similar to this, the access point is going to manage only the data traffic. Whatever the management and control traffic, it is going to push to the WLC. Similarly, sorry, just taking one step forward. So now when the access point is managing, it is facing towards the client and managing the data traffic, it is switching the data traffic between the clients. The management and control traffic, it goes to the WLC via the protocol that is called as CAPWAP. Okay. And even the data traffic can also be put on the CAPWAP. Okay, but it is not encrypted. By default, the control traffic is encrypted. So the AP puts the data onto this tunnel, layer 3 tunnel that forms between the access point and the WLC. So that tunnel is nothing but the CAPWAP. Okay. And there is two CAPWAP tunnels that will be formed, that is for the control traffic and the data traffic. And this will be secured by the DTLS. Okay, that is secured by the DTLS. This is the packet. Yeah. So we will stop here for today. Just to summarize what we have learned today, we have learned about the attenuation, different forms of attenuation, which can affect your transmission over the air. And next, we have learned the VSWR. What is the significance of the VSWR? We have understood. Then we have taken into, then we have been learning this WLC and AP. So where this WLC sits in the product, where the AP sits, what is its functionality, how they are communicating. So this is what we learned today. So in tomorrow's session, we will take one step further and we would be learning more about the DTLS and the AP join process. Okay, if possible, we will try to register a AP to a WLC and try to do a packet capture and see how the messages are communicating between the AP and the WLC. So that's in the next classes that we would be seeing. So there is a AP join process. So we will go step by step with this. Okay. So that's what is the day today? So today already we are Thursday. So Monday we will start this fresh topic, the AP join process. Okay. A little bit about DTLS and all. We will talk and then we'll start the AP join process. I will showcase the lab. I will show how these two are communicating. We will do some packet capture in the Wireshark and see what is it going in behind. Okay. So that we can do on Monday. All right then. Thank you for joining today's session. I hope it was a great learning for you today and we can continue on Monday.